Today we are going to see the principle of operation of a transmission grating. This is a diagram of a grating plane. These are the slits. These are the slits. The slits are separated by some distance. This is A. The separation distance is A. It is called pitch of the grating. So in here a source is placed, which is far enough from the grating plane. Similarly, a plane, and known as the imaging plane, is also far enough from the grating plane. This is the angle of incidence of the signal coming from source, and this is the diffracted angle. So, consider the light to be transmitted from the adjacent slits. So, the light is transmitted from the adjacent slits. We assume, and the distance between the adjacent slits is called the pitch of the grating. It is denoted by A. And as I said already, we assume a light source is present, which is far enough from the grating plane, and it is greater than A. The angle of incidence of the incoming signals is theta I. And so, since the slits are very small in size, diffraction takes place and it is diffracted at an angle theta d from the grating plane. And we assume another plane known as the imaging plane, which is far away from the grating plane, and it's greater than the grating pitch A. Now, as per the diagram, the slits are very small enough, and it is very small compared to the wavelength of the light. So, since they are very small enough, we assume the phase change is negligible. So, we assume phase change is negligible, but we calculate the path length difference as the rays travel through the adjacent slits. So, what is the path length difference means? It is a difference in length between the line segments. This is AB and CD. Difference between this AB and CD is the path length difference. And by using the trigonometric formulas, it is calculated, and it is found to be A into sine theta I minus sine theta D. So, next is whether constructive interference or destructive interference is occurring. So, constructive interference occurs at a wavelength at the imaging plane if those rays satisfy the grating equation. What is the grating equation? A sine theta I minus sine theta D is equal to m lambda. M is an order of grating. It is an integer value. If this equation is satisfied by the rays means, then constructive interference will be occurring. So, what is the use of this grating? So, this grating is used to separate the individual wavelength. In a multiplex signal, that is in a wavelength division multiplex signal, we can separate the wavelength. So, at different points of the imaging plane, the grating equation is satisfied. The grating equation is not satisfied at a single point, but it is satisfied at different points in the imaging plane for different wavelengths. See, theta D1, this is theta D, it is a diffracted angle for the incident ray. Suppose we have taken number of slits, number of incidence rays will be there, theta I1, theta I2, theta I3 and so on. Similarly, for each and everything you will be having diffract angles, theta D1, theta D2 and so on. So, whenever they satisfy the grating equation, you will be getting a maximum interference. What about the energy? The energy for particular wavelength is distributed over all the angles that satisfy the grating equation. So, suppose if I am using a grating as a demultiplexer, means light can be collected from only one of these angles and the remaining energy in other orders is lost. So, this grating performs the function of demultiplexers and most of the energy will be present in the zero order mode. So, the zero order mode, when it occurs, means it occurs when theta I equal to theta t. The angle of incidence is equal to angle of diffraction, means this all the energy or most of the energy will be concentrated in the zeroth order mode. See, but when all the energy is concentrated in the zeroth order interference, we can say it is wasted because the wavelengths are not separated here. All the wavelengths will be present here. So, it is a waste of energy only. So, we have to design the grating in such a manner that light energy is maximum at one of the interference maximum. So, this can be accomplished by using a technique called blazing. See, the shape of it has been changed. So, this alpha is called the blazed angle we see. So, in here, the reflecting slits are inclined at an angle alpha to the grating plane. So, they are inclined at some angle. So, this will maximize the light energy in the interference maximum. Next, diffraction pattern. We already know that the slits are very small and they are very small, less than the wavelength. Phase change, in the previous case we assume it is neglected, but we can't be neglected because phase change, path length difference are all related. Now let us consider slit of length W whose length varies from minus W by 2 to W by 2. So, light diffracted from position Y at an angle theta on the slit has a relative phase shift of phi of Y is equal to 2 pi Y sin theta by lambda. So, relative phase shift it is having. When a light is diffracted at a position Y, the position that is Y value can be between minus W by 2 to W by 2. Minus W by 2 to W by 2 at an angle theta. So, it is having a relative phase shift of phi of Y when compared to the light diffracted from Y is equal to 0. So, phase shift is there between the light diffracted at the position Y is equal to 0 and some other position. Then what about the amplitude? Amplitude is denoted as A of theta. So, the ratio is taken between 0th angle as well as some variable theta. So, A of theta by A of 0 is equal to sin pi W sin theta by lambda pi W sin theta by lambda. In the diffracting aperture or slit, we can describe the slit or aperture by f of Y. Then the formula can be simplified as A of theta is equal to A of 0 some integral between minus infinity to plus infinity f of Y. This is a function of the slit exponential 2 pi I sin theta Y by lambda into dy. So, intensity distribution, that is amplitude distribution, is denoted by A of theta. Intensity distribution is given by modulus of A of theta the whole square. Then what is the value of Y, f of Y? F of Y, it describes slits. F of Y is equal to 1 by W if Y is less than W by 2 and f of Y is equal to 0 for other cases. Thank you.